Okay, so this video is going to be based on the division of complex numbers, and the main term I want you to remember from this video is complex conjugate, because it is very, very important. Now, when I say division of complex numbers, I mean when you're dividing by a complex number. If you're dividing by a real number, it's no problem. It's very awkward when you have to divide by a complex number. Now, what is a complex conjugate? Okay, so if I have just this complex number below, z equals a plus bi, I can find the conjugate of that. It's written as z bar. Okay, there's a line on top, so I'll write it in black actually so you can see it better. Z bar. So it's the same as z, but there's a bar or a line on top of it, so that's called z bar or z conjugate. Now, if a plus bi is going to be z, the conjugate is a minus bi. Okay, the only difference is you change the sign of the imaginary part. Okay, I've wrote just IM just to make it a bit easier, but you change the sign of the imaginary part. So for example, if I have 1 plus 2i, so if I say z is 1 plus 2i, z bar or z conjugate is 1 minus 2i. Okay, the real stays the same, the imaginary just changes sides. If I say z is 4 minus 6i, z bar in this case would be 4 plus 6i. Okay, now what if the example says z3, because it's the third one. What if we say the complex number is minus 5i? What's the conjugate of minus 5i? Well, as I've explained above, you change the sign of the imaginary part. There's no real parts written down, but there's actually 0 real parts. So there is a real part there, it's just hidden, it's a 0. And you change the sign of the imaginary part. So z3 is here, z3 bar or z3 conjugate, whichever you prefer to call it, that minus 5 becomes plus 5i. So that's how you relate a conjugate. That is what the complex conjugate is. You change the sign of the imaginary. So plus 2 minus, minus 2 plus, minus 2 plus. So now, what's the whole point of getting the complex conjugate? Now I'm just going to show in a slight example what happens when you use a complex number with its conjugate, but the division part is another trade off of that. So I'm just going to explain this first. So what I want to do is, I have z1 here. So what would happen if I had z1 multiplied by z1 bar or z1 conjugate? What happens? So z1 is 3 plus 4i. Straight away I'm going to find the conjugate, z1 bar. The conjugate of that is, I don't know if you can see that bar on top there. So z1 is 3 plus 4i, z1 bar is 3 minus 4i. And now, similar to what I had in my multiplication video, you just substitute z1 and z1 bar with z1 multiplied by z1 bar, and we'll see what happens. So you get 3 plus 4i multiplied by 3 minus 4i. And now if I expand, 3 by 3 is 9, 3 by minus 4i is minus 12i, 4i by 3 is plus 12i, plus 4 by minus 4 is minus 16, I multiplied by I is I squared. Do you remember from the last section I had I squared? That's very important. The minute you see I squared is minus 1. Any time at all you see I squared, you can change it to minus 1 straight away. So we have 9 plus 12i minus 12i, they cancel. Minus 16, so I'll put a line through just so you know. Plus 12 minus 12, they cancel. Minus 16 multiplied by I squared, which is minus 1. So that gives us 9 plus 16, so the answer is 25. Okay, now what's the whole point of that? Z1 is a complex number with an imaginary part. Z1 conjugate is a complex number with an imaginary part, but when you multiply a number by its conjugate, it eliminates the imaginary part. And that's very, very, very important for the next section or the next part of the video, where you can only divide by a real number. Okay, so this is the first example on it. Now, you might think this is a bit strange having money in the complex number section, but this will help explain why. So, say you started off with €100, and I said to you, look, whatever you have, so you have €100, I'm going to multiply that by 5. And I'll give you that much money, which is grand. So 100 multiplied by 5, all of a sudden, you now have €500. I said, right, grand, you have €500, that's grand. But now what I'm going to do is divide this amount of money by what I originally multiplied by. So I've multiplied by 5, now I'm going to divide by 5. So 500 divided by 5, that gives me 100. So now, you've just gone from €100 up to 500, then I've divided by the same number. I multiplied by 5 there, I've now divided by 5, and you're back to your original number. So what's the whole point of this part? Basically, if you multiply and divide by the same thing, it doesn't change the value. It's exactly the same. Okay? If you multiply, say, take the number 10. If you multiply the number 10 by 10, you get 100. But then if you divide by 10, you go back down to your original value of 10. If you've 6 and you multiply that by 3, you get 18. 18 divided by 3 is 6. So as long as you multiply and divide by the same thing, it doesn't change the value. Now that part is very important for this example. So the example I'm going to use is 3 plus 4i divided by 2 minus 5i. Okay, so now I've gone to a complex question with a complex divisor. We don't want to divide by an imaginary number. You can't. How could you divide by something that doesn't even exist? It doesn't make sense. So what I'm going to do, this is the important part, I'm going to multiply above and below, which is the same as multiplying and dividing, above and below by the conjugate of this one. So if we have 2 minus 5i is, we'll say that's z. Z is 2 minus 5i. The conjugate, z bar, or z conjugate, would be 2 plus 5i. So the conjugate of the denominator is plus 5i. So what I'm going to do is multiply and divide by the conjugate. So I'm going to multiply the top line by 2 plus 5i, and then divide by 2 plus 5i. Okay, similar to what I did up here. I multiplied 100 by 5 and then I divided 500 by 5 and it got me to where I was. It didn't change the value. Same here. I'm multiplying above and then dividing by the same value. The same number. It doesn't change the value because I'm doing the same thing above and below. So now what I'm going to do is just multiply straight across and see what we get. We've 3 plus 4i multiplied by 2 plus 5i, all divided by 2 plus 5i, 2 minus 5i. Now I noticed now I just swapped those, but because it's multiplication it doesn't matter, so you can just carry on. 3 by 2 is 6, and 3 by 5 is 15, and the I at the back. 4 by 2 is 8, and the I comes in as well. Plus 4i plus 5i is plus 20 I squared. Again, there's your I squared, so you have to be very careful. The bottom line, 2 by 2 is 4. 2 by minus 5 is minus 10i. Plus 5i by 2 is plus 10i. Minus 10 plus 10, they're going to disappear. Minus 5, plus 5 by minus 5 is minus 25i squared. Now, on the last section I showed if you multiply a complex number by its conjugate, it becomes a real number. That's what's going to happen here. Okay, so I'll just do the bottom line now just to show what happens. First, 4 minus 10i plus 10i, they disappear. Minus 25, that's okay. I squared is minus 1, so now the bottom line will be 4 minus 25 multiplied by minus 1. The imaginary part is gone. We have no more imaginary numbers in the denominator. Now, if I just clear up the top line, 6 plus 15i plus 8i plus 20 I squared, which means you multiply by minus 1, and they're all divided. Clean up the top line a small bit. 6 plus 15i plus 8i plus 20 by minus 1 is minus 20. Use the ruler to make it a bit easier. All divided by 4 minus 25 by minus 1 is plus 25. So 4 plus 25. Next line, if you want, because it's now getting a bit more complicated, you can go back to your red and black pens. So the red for real, black for the imaginary. We have 6 minus 20 plus 15i plus 8i. And the bottom line is just real numbers, so that's okay. 6 take away 20 is minus 14. Plus 15 plus 8 is plus 23i. All divided by 4 plus 25 is 29. And now it doesn't say it in this question, but it's good to get into a habit of it, where you write it in the form a plus bi. So you have distinctly the real part and the imaginary part. So what I'm going to do with this is just take the 29, it goes under the 14, and it can split up under the 23 as well. So my final answer would be minus 14 over 29 plus 23i over 29. And that is how you solve a complex conjugate question. You take your complex number, multiply above and below by the conjugate of the denominator, and it's just simple algebra then after that.